equilibrium, an object equilibrium. Equilibrium. Equilibrium is a very important concept in civil engineering, mechanical engineering, and so forth. Because when we build a house, we want the equilibrium. We want a solid lay on the ground, not like something in China. The wind blows and the whole building collapses. Just like this. I think that Taiwan just the same thing happened in the August 8th typhoon, and the whole building collapsed. United States is very lucky, especially in California. For us, I see so many earthquakes in my lifetime. I treat it like a rain, sickly rain, and so on. Because our building is built by wood, so it's very flexible. So we basically, I see my house is sinking like this. So again, so and then a little bit is covered. So, but equilibrium is important now. So right now we have a force, push this, then it's move. So that's why we said if an object has no motion, the first requirement is summation of F equal to 0. So this is the no motion, right? Now, if you have a thought, a drop, okay? So that in order for equivalent for a solid object, we need one, the summation of F is equal to 0 at any point. And then, in order to, this is called no linear motion. No linear motion. And then the next one, for it has no rotation motion. If there's no rotation motion, the summation of the tau is equal to 0. And that is no rotation motion. So what is called equilibrium? Equilibrium means in physics, equilibrium equal to, in physics, equilibrium equal to no linear motion and no rotation motion. There's no rotation motion, no linear motion. So another point of view is if you put this, for example, you suppose this is a ladder. You put it against the wall before you climb up to the ceiling, right? So make sure that this equilibrium. Okay. So we did a lot of things based on equilibrium. Then maybe we'll have a test, a problem will come up for this equilibrium problem. The first good example is on example 10.8. Example 10.8 is kind of difficult because it's a lot more complicated. Example 10.8 is somebody have a wall, and then they hanging a bar out there with the strings attached. String attached to that. So push like this. So that means this corner suffer a lot of stress, and this wire needs a lot of tension. And here has a guy stand up on here. Okay, that causes another forces push it down. So if you look at this, it has a force diagram. So in order to solve this equilibrium problem, number one, you have to consider the force diagram. Obey the summation F equals 0. And then you see the torque diagram, make sure summation of tau equals 0. The good example in this is it's not too difficult, it's not too it's not too impossible. Is the example on 10.9. 10.9 is a very good example. Example 10.9. So what they're talking about is talking about painter. So painter is lean a ladder to the wall. Okay, like this. So first they lay down on the wall. There's a lot of force action here. First, there's a center of mass is on here. Center of mass, assume all the mass is concentrated at one point. Usually, it's at the center of a center of the ladder. And then, now, this wall, when you're reading the English, the wall has, when it says smooth, it has a meaning. Means no friction along here. No friction along the wall. No friction. Along the vertical wall. So this is understood. So when you read English, got to be read the problem, got to understand what it is. For example, in the before chapter 6, it said a drop. What does it mean? Drop means V sub I equals 0. When you throw, then the V sub I is not equal to 0. So in the wall, it says smooth means no friction. So if there's no friction, what happens? There's only force push it vertically. Okay? So now, if this is not sliding down on this ground, there must have a frictional force on this. And then they must have a normal force in there. So in that cases, they have this one they classify as F sub F. In these cases, this is called normal force because it is normal to the ground. And then this one have a force push it back. In this case, is a P. So in here, right away, in order for this ladder to be stable equilibrium, summation of F equal to 0. If it's summation of F equals 0, what does that mean? You should summation F sub X equals 0, summation of Fy equals 0. And right away, this is solvable. That means that all the vertical force add up equals 0. So why? This is vertical force, this is vertical force. These two cancel each other. And then what is the horizontal force? Horizontal force is one force to here, one force is in there. So that is equal to 0. So a summation Fx equals 0, summation Fy equals 0. Then it doesn't guarantee that it might rotate. So in order for this rotation to occur, then you have the summation of tau equal to 0. Tau is a torque. Torque have a two direction. One is rotation. Another one is cause the object counterclockwise, clockwise rotation. That means if you want to break it down, summation tau is called clockwise. Equal to 0, summation of tau, in which case is counterclockwise. Oh, I'm sorry. I used the wrong word. That means you have to figure out tau clockwise, and then press a tau counterclockwise. All that equals 0. So you balance it out. So when you're doing this, you got to make sure what is cause clockwise rotation, what causes what we call the counterclockwise rotation. So look at it. So if you take this as a motion axis, right at this point, how nice is it? Because you don't have to worry about this, you don't have to worry about that. But if you want to take this as a motion object, what will happen? You have to take all these forces in account. So sometimes you have to smart. You pick the easiest, less to worry about. So if you pick this forces is cause this ladder have clockwise rotation. It's going this direction. So suppose that this one, the P, just the opposite. This cause the counterclockwise rotation. So that's what you have to take into account. And that the angle is different, so you have to watch that too. So anyway, so look at the, give you the major hint. The hint is this. There's a problem on the second midterm. Is similar like this, but we want to add in something there. Right now, the people is doing the painting, mostly cost effective around the Southern California area is Korean. I'm sorry. Korean painter is very cost effective. Usually ask them to do the painting for me because nobody can beat their price. They have a whole crew come in, and then within 2 or 3 hours, the thing is done. The 2-bedroom apartment is completely painted. Okay, so in order for the climate there, so we put a painter on the top here, and the force is coming down. Something like that will be on the second midterm. See how nice the teacher is? Basically, inform you some kind of problem like this. Now, you have to go home, set up something on yourself, try practice. Isn't that fair? Fair enough, right? Okay. All right, so anyway, we've done this already. So we like to take a break, and then when we come back, we will talking about 10.8 for angular momentum.